Good morning. I'm going to go over this worksheet, escape velocity. Escape velocity is when we have a rocket, say on Earth, and we want to get it out into space. Escape velocity is how fast you need to go in order to leave the gravity well of that planet or star or whatever it may be. Now, the larger the planet, the stronger the gravity, which means the higher the escape velocity. You got to go faster to get away from a large planet than you do to get away from a small planet. Now, there's a couple of things that you want to think about here before we start talking about escape velocity. So, if I have a cannon, so I'm going to just draw a cannon here, and I shoot the cannon. If it's going a certain speed, that cannon is going to follow a path, but eventually hit the planet. It'll hit the surface of the planet again. If I shoot it a little bit faster, it'll go farther before it hits the planet. But the gravity's still going to pull it back to the planet. If I keep increasing the speed, if I go faster, if I shoot it faster than that, I can eventually get it to follow this path where it's falling towards the Earth, but it's going fast enough that it actually orbits the Earth. So this is kind of a weird concept. When something is orbiting the Earth, it's actually constantly falling towards the Earth, but it's going at a speed that matches this curvature of the Earth. So when astronauts are in the International Space Station orbiting the Earth and they're in free fall, like there's no gravity, well, gravity is actually applying forces to them, but it's just that they're continuously falling towards Earth. They're in free fall. That's why why it appears that there's no gravity affecting them. And that's what we see in this picture here. We launch rockets at a very specific speed so that once it gets to that speed in the proper orbit, it's just constantly going in a circle and falling towards Earth in a smooth circle, but never actually hitting Earth. Okay, and if we want to leave the planet, if we want that rocket to go to another planet, we have to go even faster, and then we can escape that pull of gravity. So we're going to talk about the different planets in our solar system. We have Mercury through Neptune here. I've got the mass. Now remember, the mass is going to tell you which escape velocity is higher. So here's what we're doing. We're using greater than, less than symbols to indicate which planet has the higher escape velocity. So I look at Venus. Venus has a mass of 4.87, 10 to the 24 kilograms, okay? Mars has a mass of 0.642, 10 to the 24 kilograms. So which one will have the higher escape velocity? Well, it's gonna be the bigger one, the one with more mass. So that means Venus. Greater than. Venus is gonna have the higher escape velocity. Now let's look at Earth and Uranus. Earth, mass of 5.97. Uranus has a mass 86.8. So Uranus is more massive, it has more gravity. So the escape velocity from Uranus is more than it is from Earth. So Earth, in this case, is less than Uranus. Uranus has the higher escape velocity just because it has a bigger mass. Do that same thing for each of these groups using your greater than, less than symbols between them. All right, hope this helps. Thanks.